All right, hello everyone once again. Today we're continuing with DBE for NSC Physical Sciences Grade 12 paper from November 2023. So this is paper 2 dealing with chemistry. Questions 1 through 7 have already been done in previous videos. In this video, we're looking at question 8. Question 8 is to do with some electrochemistry. So changing gears from some of the previous questions. And I believe this is the second last question of the paper. Question 9 also deals with some electrochemistry. So let's get into question 8. A clean, pure copper strip is placed in a beaker containing a colorless silver nitrate solution at 25 degrees Celsius as shown below. So just to point out a couple of things, they do make a point of saying 25 because when we scroll down to come have a look at our reduction potentials table, these are standard reductions, and standard basically means these are reductions taken at 25 degrees Celsius. So that's just why they're pointing out the temperature, just so that we know that those are the relevant tables that we need to use. All right, carrying on with the preamble to the question. After a while, it is observed that the solution in the beaker becomes blue. Okay, so this is interesting. So there's some reaction going on between the copper strip and the silver nitrate solution. Okay, so first of all, write down one other observable change besides the solution turning blue. So there's a couple of changes that we would expect. What what we should know already is that the copper is being replaced, or rather is replacing the silver in solution. So copper is basically, for lack of a better word, it's essentially dissolving, but it's a bit more of, yeah, it's a different type of reaction, but it's essentially dissolving in the solution. The copper atoms are replacing the silver atoms or ions in solution. So we would definitely expect our copper strip to get thinner, get smaller. That's one one observation. The other is because this is sort of like a displacement reaction. We're basically booting silver out, and it should form silver solid. So we should get some silver solid forming, maybe as little particles, perhaps collecting on the copper strip or just floating suspended in solution. So yeah, we should see some silver particles forming. And yeah, also uh, the copper strip could become silver plated if the silver deposits on this copper strip as a substrate. So those are some of the answers you could see, but the most obvious one is definitely that we expect the copper strip to get thinner, to lose mass as the copper goes into solution. All right, moving on to 812, the name or formula of the oxidizing agent. Okay, so um, this is where it gets a bit interesting. So how do we know which is the oxidizing agent and which is being oxidized and which is being reduced? So this is where these tables, these tables down here come in handy. So I've just gone and highlighted what we have here. So first of all, well, it doesn't matter whether we have copper 2 or copper 1, but we can see that the half reaction for silver is much higher. So it has a higher potential than both half reactions for copper. So it doesn't matter what copper species we have, both are below silver. So this tells us that silver is the oxidizing agent. You just got to know this. The oxidizing reagent will always have a higher reduction potential in your system. So for 812, we simply know that this is Ag plus. It's important that you say Ag plus or silver ion, and you don't just say Ag or silver. Um, this is wrong because it is the ion that does the work and not the parent atom. Yeah. Okay. Moving on to 8.2, explain the answer to 8.1 with referring to the relative strengths. Okay. So it's just as we've done, we could just quote the reduction potentials from the table and explain that the higher reduction potential means it's the oxidizing agent. So put it into words, you could say the Ag plus ion is a stronger oxidizing agent than the copper ion. I believe it's copper 2 plus in this reaction. So, okay. But even if it was copper plus, it would still be true. And therefore, it will oxidize copper to, well, copper solid to copper 2 plus. Yeah. So you could phrase it a couple of different ways, but that's basically it. And you could quote the reduction potentials from that table to back your answer for the full 3 marks. Okay. Moving on to 8.3. A galvanic cell is now set up using copper and silver strips as electrodes. Okay. A simplified diagram of the cell is shown below. So we have our 2 electrodes. It seems they don't tell us which is which. We have a voltmeter, we have a salt bridge, and we have our electrolyte. So it seems they've told us that for the one electrode, the electrolyte is silver plus, and we don't know what the second is. Okay. So write down the name or formula of electrode A. Okay. So this may seem pretty obvious, but um, the electrolyte has to match the electrode. So if we have silver plus as the electrolyte, and we know that our 2 electrodes are either copper or silver, then A has to be silver. So you just look at the electrolyte and you know the electrode has to match. Next, name or formula of solution B. So B, since we know that this is definitely the copper electrode, so copper solid, then B has to be some solution of copper. So yeah, could be a couple of things. Let's just put down, you could simply just put it down as copper 2 plus, or you can write an actual electrolyte, so maybe copper sulfate is an answer, but copper 2 plus is sufficient. This is sufficient, copper 2 plus. Okay. Overall net balanced equation for the reaction. So let's write it down. So we know that we have silver plus aqueous reacting with copper solid, um, and this is going to form. We know that the silver oxidizes copper. That's how we know that we start with this and not with copper plus and silver solid. We know that silver plus is the oxidizing agent, so it starts this way. And this goes to silver solid. And since this is just the net equation, we don't have to put in spectator ion, so we can just say copper 2 plus. Yeah. And let's realize that this is 2 plus and this is 1 plus. So it actually takes 2 silver ions to oxidize copper metal to copper 2 plus. So this needs to be 2 as well. The charges have to balance. So that's basically the trick to this one, is just realizing that the charges have to balance. So this is our net balanced equation. I can just clean this up. Okay. The salt bridge contains potassium nitrate. All right. Write down the formula of the ion in the salt bridge that will move into the silver solution. Choose from K plus or NO3 minus. Give a reason for your answer. So now this one's a bit tricky. It's a bit tricky because which is the correct one? What we need to realize is that because we're using up silver plus, so we're using up from our equation, we're using up silver plus, and we're forming silver solid. Therefore, it's the positive ions, the K plus, that'll move to balance out everything, because we're losing our Ag plus to form solid silver. Therefore, it's the K plus that'll move in this side to balance out everything. So that's basically just what you have to realize. If the system was set up differently, it could have been the nitrate ions, but essentially that's the reason. So yeah, it's K plus. The reason being we're using up Ag plus, so K plus has to move to balance out everything to maintain electrical neutrality. Okay, and that concludes the question. Yeah, this was a really quick question. It's only 12 marks, but it is important just to break down the question to make sure you have all the pertinent information before answering, because you can easily get mixed up with all these different things. And just remember the couple of rules along the way that I mentioned, and this should be fine.